Hello and welcome to today's lesson. Today we're going to be covering lesson 2-2 in our Go Math book, and we're going to be talking about scientific notation and standard form. So we're going to be talking about positive powers of 10 today. All right, I just want to do a quick review on 2-1, and 2-1 we were dealing with exponents. And there's some different rules that we were using that when we were talking about exponents. So one of the rules that we had was something like x to the negative 7th power, and how mathematicians say that this is not in simplified form, so that we need to write this as a fraction as 1 over x to the 7th power. Then we went on and we talked about something like w to the second times w to the third. And what do we hear? Well, they all have the same base. So the first rule is that we keep the base. Okay, so the first thing is they have to have the same base in order for do anything. So we're going to keep the base. Okay, so this answer would be keep the base. And now what do we do with these exponents? And if you recall, we are going to add exponents. And I picked this one just because, remember, on this w, what number is not written there? So we're going to go 2 plus 1 plus 3. So this answer would be w to the 6th power. So we're going to keep the base, add the exponents. All right, then we did something like a power to a power. So if we had x to the 4th power, and then we took that to the 5th. So this is what we would call a power to a power. And this time we are going to still keep the base, and we are going to multiply exponents. So this would be 4 times 5, and so we get x to the 20th. And then the last one we did was something like this. If we had x to the 9th over x to the 4th. So when this is dividing, we still keep your base, and we are going to subtract our exponents. So we have x to the 5th. Notice we have more x's on top. We have 9 of them, and only 4 in the bottom. Likewise, if it were written like this, x to the 3rd over x to the 10th. Okay, do you see how we have more x's on the bottom? So this one is going to be 1 over x to the 7th. Do you see how we have the 7 in the bottom instead of on top? All right, so that's just a quick review before we go on into our scientific notation. So our learning target for today, learning target is going to be I can write large numbers in scientific notation with positive powers of 10. So your learning target is I can write large numbers in scientific notation with positive powers of 10. All right, we're going to do a little experiment here, or a little thing where we're talking about some powers of 10 here and some larger numbers. So in this chart here, we have some different sea creatures. We have a blue whale, a gray whale, and a whale shark. So you guys can go right along in your book and open up your book to page 39, and you guys can write down these notes as we are going through them. So open up your book to page 39. If you need to dig out your book, then just pause the video. All right, part A says move the decimal to the left. Okay, now remember we've talked about this. Decimals are always understood to be at the end of the number, just efficient mathematicians don't put them in. So now it says move the decimal to the left as many places to find a number that's bigger than 1 but less than 10. So if I just move the decimal right here, I would have the number 250. Does that fit that it is greater than 1 and less than 10? Nope, that doesn't fit there. So what if I move the decimal over one more place and now I have 25? And the answer is still no. So I need to move it over one more, so it would be 2.5, and then you can put those zeros in there if you want. So divide that by 250, and what do we get? and we write our answer as a power of 10, and so we're going to have 10 to the 5th power. So if you grabbed a calculator and take this number, 250,000, and divide by 2.5, you're going to have something that's going to have a 10 to the 5th power. All right, so they want us to combine our answers for A. So I do not need to write all of these zeros after it. So I'm just going to put 2.5. And then in B, they asked us to write that as a power of 10. So they already wrote the 10. And we're going to put the 5 in there. All right, then they want us to repeat that. And they want us to do the whale shark. So go to the end one. Move the decimal over. So if I stop right here where that comma is, it would be 41.2. That is not between 1 and 10. So I have to move it one more place, 4.12. And now if you divide that out, you're going to get something that goes to the 4th power. Okay, now they want us to look, how many places did you move that decimal? Well, if we start here and my decimal goes 1, 2, 3, 4 places, and look at what this exponent is here. Look up in the blue whale and how many did I really move it? 1, 2, 3, 4, 5 places, and look what that exponent is right there. Is that a coincidence, or is that what is always going to happen? However many places you move that decimal, is that what the exponent is going to be? So let's try some other sample problems here and see what happens. So it looks like they have 84,000. So the decimal's here at the end, and you can see they went the loop, 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 loop to get 8.4. 8.4 is a number bigger than 1 and less than 10. And how many places did they move that decimal? Well, you can count here the number of bubbles, 2, 3, 4 bubbles, and that's why they have the exponent of 4. Now, if we look at this next example, so what's that, 93 million? So if we move that decimal over, well, this to this comma is 3, to this comma 6, and now that would still be 93. We have to go one more place, so it becomes 9.3. And then in scientific notation, we write times 10. Now, how many places did we move that decimal? Well, if we count the 3 here and the 3 here, and we had to go one more, that would be moving it 7 places. So that's where they get this answer, 9.3 times 10 to the 7th. All right, stop this video, pause it, and then you try these. See if you can put these in scientific notation. Remember, the first thing you want to do is write a number between 1 and 10. Okay, write a number. It has to be bigger than 1, and it has to be less than 10. Okay, that's your first thing. First job, write a number that is bigger than 1 and less than 10. And then your second job is going to write times 10. And the third job is you're going to find your exponent. Okay, and we do that by counting how many places we move that decimal. So go ahead and pause this and then give these 3 problems a try. All right, you're back after the pause. So number 1, write a number bigger than 1. So we're going to go put that decimal, so we have 6.4. Okay, so if I'm going to put that decimal right here, then I write times 10, so I don't forget writing the times 10. Now, if that decimal's right there at 6.4, how many places did I move the decimal? There's 1, there's 2, there's 3. That number is what becomes our exponent. And number 4, I just go look at the beginning, so I'm going to have 5.7. That's a number bigger than 1 and less than 10. Step 2, write times 10. Okay, so I put that decimal right here between the 5 and 7. Now count, how many places did you move that decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like we moved it 11 spots. All right, then they want us to take this other really big, ginormous number here and write it in scientific notation. So again, that first number, 9.4, 4, 6, 1. That first number needs to be bigger than 1 and less than 10. Step 2, write times 10. So we put the decimal right here, 9 and 4. So how many places did we move it? Well, we can count the commas, kind of. So we go 3, 6, 9, 12. So that exponent would be 12. Notice these are all really big numbers, 93,505,700,000. They're all really big numbers here. So make sure that this is a positive exponent. Okay, eventually we're going to be talking about small numbers, and those would be not positive exponents, but negative. All right, so now we have to go the other way. If something is in scientific notation, can you go ahead and put it back into standard form? So because that is a positive exponent, we're going to move that decimal to the right because we're going to get a bigger number. So we have to move the decimal one place beyond the 5, so that's 1. Then you have to go 2, 3, 4, 5, 6, and you fill all the rest of these loops in with zeros. So you can see right here they added in all the rest of the zeros, and so we get the number 3,500,000. Okay, now if you count, there's only 1, 2, 3, 4, 5 zeros, but when you look at the problem, there were 6 was the exponent. Why aren't there 6 zeros instead of only 5? Can anybody think of that? Okay, and the reason is because that decimal is right here between the 3.5. We need one place to get beyond the 5, and then we fill the rest of them in with zeros. So that's why there's only 5 zeros instead of 6. All right, a couple here down at the bottom. So this is a positive exponent, so we're going to have to move that decimal 9 places. But look here, we already have numbers, so we have to get 1, 2, 3 places there. So we only are going to add 6 zeros on the end. 7, 0, 3, 4. That is moving the decimal 3 places already. Then 4, 5, 6, 7, 8, 9. And since we already moved it, you can count 1, 2, 3, 4, 5, 6 places to get your answer. All right, number 9, moving the decimal 5 places to get this. So we have to get beyond the 2, beyond the 3, beyond the 6. That's 2 places. So 2, that's 1, 2, 3, 4, 5. Now we have moved that decimal 5 places, so it's 236,000. Okay, now in the first 2, we had to get beyond those decimals, the 034 or the 36. When you look at number 10 here, there isn't anything. There's no decimal, no numbers after it. So in this one, we're actually going to put down 6 zeros, because the decimal was right here by the 5, and then we move it 1, 2, 3, 4, 5, 6 places. So this becomes 5 million. All right, so here's your assignment here. So I'm gonna give you guys some problems to do. So you guys go ahead and do those problems. Then you can jump back, and in the second video that we will have for today, we will be correcting these problems. So good luck on your homework.